I'm Deb Sarna, and I'm going to be talking about cloud computing, what it is, and how it helps solves real problems. Um, so a little bit more cloud. So when we think about cloud, we often imagine something up to the sky. But in technology, the cloud simply means servers and data centers that we access over the internet. Instead of saving files and running programs on our own computer, we use online platforms that handles all of it. Um, with cloud, it changed how we store data, run businesses, even how we stream movies, play games. Every time we use like Google Drive, or watch Netflix, or check our email, like we're using or you're using cloud computing. Um, Okay, so what is cloud computing? Cloud computing is basically using the internet to get access to computing services like storage, servers, softwares, and database without owning a physical like hardware like yourself. So think of it as like kind of like renting or buying. Instead of like buying an expensive computer, server, or maintaining it, a company can rent space from a cloud provider such like Amazon Web Services, Microsoft Azure, or Google Cloud. Um, you pay for what you use, kind of like an electricity bill. If you use more power, you pay more. If you use less, you pay less. Um, this just makes it more easy for businesses and like day-to-day people to store data, again, like run apps or even create websites without the hassle of worrying about where all the files are physically like stored. Key characteristics. So there are four key traits with cloud computing, um, which are on-demand access, scalability, cost efficiency, and accessibility. Um, for on-demand access, which means you can get what you need anytime, like instantly opening a document from your phone or being able to just click on your Google Drive and work in it. Scalability, you can quickly increase or decrease your resources. For example, like a business can add more server space during their busy season and scale down afterwards. Cost efficiency is another really big benefits with cloud computing because no more buying expensive equipment that just sits and get unused. Um, and then accessibility, anyone can log in anywhere, where whether you're at home or in your office or traveling, it's kind of having that at your fingertips whenever. Okay, types of cloud computing. There are three main types of cloud computing. There's LAAS, PaaS, and SaaS, which stands for Infrastructure, Platform, and Software as Service. Okay, so LAAS provides the basic building blocks. There are virtual machine, storage, and networks. It's like renting a digital warehouse where you can set up whenever you want. An example of that is AWS EC2. And then there's PaaS, which gives you tools to build and test applications without managing servers. This is really popular with developers because it lets them focus on coding instead of the setup. An example of this would be like the Google App Engine. And then SaaS, which I feel like it's more commonly heard. It's basically a ready to use software. So, like your Gmail or Zoom, you just log in and start using it. No installation and no maintenance. Problems that are solved by cloud computing. So problems that are solved, we can basically start with the cost. It eliminates the need for expensive hardware. Companies pay only for what they use, which helps small businesses compete with larger ones. Um, Limited storage. The cloud provides practically unlimited space. So you can store photos, documents, or database without worrying about running out of space, running out of memory. Um, Disaster recovery is another big one. If your computer like crashes or your data is lost, backup stored in the cloud can be restored in minutes. And it also solved the collaboration problem because multiple people can edit the same document or work on a project in real time, like no matter where they are. Um, and scalability. So, like, as a company grows, cloud grows with it. No need to buy new servers, just increase your plan. Um, and then security in the cloud. Um, One like major question most people always ask is like, is cloud safe? And the answer is basically yes, if it's like managed properly. Cloud providers invest heavily in security, offering encryptions and firewalls, identity controls, and 24/7 monitoring. However, users also share with their responsibility as well. You still need strong you still need things like strong passwords, regular updates, and limited access to sensitive files. Another analogy is like, think of it as like an apartment building. The owner provides security cameras and locks, but you still need to lock your own door. So cloud security basically works the same way. It's a shared responsibility between the provider and the customer. But overall, the goal is to keep data safe, private, and available. Real world examples. So Netflix, which is most people watches Netflix. I've heard of Netflix services. But Netflix used Amazon Web Services to stream shows and movies to millions of people at once. The cloud helps with them. The cloud helps them handle all that traffic without the buffering or downtime. Um, and then Zoom. So Zoom runs its video meetings on cloud servers, allowing people from all over the world to connect instantly, which is something that became very essential since the pandemic. Um, in healthcare, hospitals store medical records in the cloud, giving doctors fast, secure access to patient information from anywhere. Like even small businesses can benefit from the cloud. So, for example, like your local bakery or coffee shop might use cloud tools for like online orders, payments, processing, and marketing, all without like owning one single server.
Hello, everyone. My name is Desmond, and I'll be talking about the leading cloud computing companies and their service models. In this section, I am going to explain the three main service models, and then I'm going to go over the top companies that lead the industry, including Amazon Web Services, Microsoft Azure, Google Cloud, IBM Cloud, and Oracle Cloud. Let's begin with a quick overview of what cloud computing is and why cloud computing is so important. Amazon Web Services, Microsoft Azure, Google Cloud Computing. Cloud computing has become the foundation of modern IT and business operations. It provides on demand access to computing resources like storage, servers, databases, and networking, all through the internet instead of owning physical hardware. There are three. main types of cloud service models. Um, One, we have infrastructure as a service, we have platform as a service, and we have software as a service. These models define what part of the computing environment the user controls versus what provider manages. Let's take a closer look at each one of them, and we're going to explain what each of them do. Starting with infrastructure as a service, this model provides virtualized computing resources over the internet. Think of it as renting virtual servers or storage instead of you buying your own virtual servers or storage of your own. Next is platform as a service, which platform as a service basically gives developers a ready-made environment to build, test, and deploy applications without managing servers. And last is software as a service. When a when a provider manages everything and you just use the software online. So in short, infrastructure as a service gives you the most control. Software as a service gives you the least control. Where platform as a service is kind of like in the middle, where it is kind of like it's just the middle ground for developers. Here we have what we call the shared responsibility model. And the shared responsibility model defines what security and management tasks are responsible or handled by the cloud provider and which responsibility is handled by the customer. It ensures that both sides understand the roles in securing data, systems, and infrastructure. In infrastructure as cloud infrastructure as a service, the cloud provider is responsible for physical data, including the storage, networking, and virtualization. And the customer is responsible for operating system configurations, data access, application, runtime, and virtual machines. And platform as a service, the cloud providers are responsible for the infrastructure and the runtime environment, which includes the servers, operating system, and the middleware. And the customer is responsible for the application code, user access, and data security. And software as a service, the cloud providers are responsible for everything that has to do with the infrastructure, the apps, software updates, and the data center. And the customers are responsible for providing access, uh, proper configuration, and protecting login credentials. Moving on to the leading companies. The first and major company is Amazon Web Services, or everybody knows AWS. It is the largest cloud provider in the world. It was launched in Amazon back in 2006. Amazon offers all three models that we just named, including infrastructure as a service, platform as a service, and software as a service. Key services include EC2 for computing, S3 buckets for storage, and Lambda for serverless computing. Its main strengths are the global outreach, reliability, and a massive network of data centers. Companies like Netflix, Airbnb, and NASA rely on AWS for scalability and security. Next, we have Microsoft Azure, the second largest cloud provider and a strong competitor to AWS. Um, Azure also offers all three service models: infrastructure as a service, platform as a service, and software as a service. And it also provides key services as Azure Virtual Machines, Azure SQL, Microsoft 360, and Azure DevOps. Azure's biggest advantage is in its integration with Microsoft products, which makes it ideal for organizations already using Windows and Office. Companies like LinkedIn, BMW, and Adobe use Azure Cloud extensively. Next, we have Google Cloud Platform, which focuses mainly on infrastructure as a service and platform as a service. Its major services include Compute Engine, App Engine, BigQuery, and Cloud AI. What sets Google apart is its strength in artificial intelligence, machine learning, and big data analytics. Companies like Spotify, Snapchat, and PayPal use Google Cloud for analytics and innovation-driven workloads. Next, we have IBM Cloud and Oracle Cloud. IBM Cloud and Oracle Cloud target large enterprise customers. IBM focuses on hybrid cloud and AI through Watson and Red Hat OpenShift, while Oracle specializes in database and enterprise applications. Both IBM Cloud and Oracle offer infrastructure as a service, platform as a service, and software as a service. And they are known for reliability, compliance, and also enterprise level integration. Um, Both of them may not be as dominant as AWS or Azure, but they are usually essential in the finance field, healthcare field, and also in government sectors. To give a quick summary of all the top providers, AWS dominates with its scale and service variety, well, whereas Azure excels in enterprise integration. Google Cloud stands out in AI and data analytics, while IBM and Oracle specialize in hybrid and enterprise solutions. Overall, cloud computing provides scalability, flexibility, and innovation, making it crucial for digital transformation worldwide.
Hello everyone, this is Dao Nguyen. For the next couple of slides, I will be discussing cloud computing deployment types and models and the cloud computing environment structure and architecture. First, we'll look at the different deployment models. The deployment model is where the organization or business wants to host their services or applications. There are several deployment methods that an organization, business, company, or individual may want to use for their applications or services. They have the option of the public cloud, private cloud, hybrid cloud, and multi-cloud. Each have their own characteristics or features that an entity may want to use. We'll get started with the public cloud. With the public cloud, it is a deployment model where all the resources and hardware of the cloud are handled by the cloud service provider. The computing resources that are available can be used by any organization, business, or users on the internet. Those that use the public cloud share the resources and hardware offered by the cloud service provider. They all get their own individual segments of the shared components, which means that the information, data, or services that they are running are their own. They aren't affected by any others that share the public cloud of the same cloud service provider. The private cloud is a deployment model where the organization can create their own cloud and it's hosted entirely by them. An alternative is that they can outsource to a cloud service provider that has private clouds, and they will run the hardware and resources, and those will be dedicated only towards the specific organization, business, or company that requested it. These are often used for companies that hold important, critical, and sensitive information. For example, a university that holds personal identifiable information about its staff or students, or a hospital that holds that as well, and important and critical patient records. The resource and hardware of a private cloud are not shared with anyone. It's only specifically for that organization. This means that the private cloud owner has the full responsibility and control of configuring and securing their cloud. This means that the entity that is hosting the private cloud can implement their own security controls and how the cloud operates or works so that it can meet their own specific company requirements and needs. Then we'll go over to the hybrid cloud. The hybrid cloud is utilizing both the public cloud and the private cloud. Companies can use a private cloud for storing sensitive information, and then use a public cloud for any services or applications that may require scalability. This helps with the workload management as one cloud won't get overutilized. An example that I thought of when I was gathering information and learning more about the cloud was about a school. A school may have a private cloud that stores sensitive information like personal identifiable information of its staff and students and more. And then for a hospital, they may store critical and important patient records. Then they have the public cloud that could be used to host a website that provides information about the school, the different degrees and courses it may offer, announcements, important dates, and more. Now we go to multi-cloud. Multi-cloud is when an entity uses two or more cloud services from different cloud service providers. They don't rely on just one singular cloud service provider. Each cloud provider has their own unique features that a company, organization, business, or an individual may want to use. So they may use one service from one cloud provider, and then they use another service from another cloud provider. Examples could be, using a public cloud from one vendor and then using a public cloud from another vendor, or using your own private cloud and then having a public cloud that's hosted by a cloud service provider. In addition, IBM mentions that the benefits include preventing vendor lock-in. This just means that they aren't dependent on a singular vendor. And then flexibility is where the cloud services, you're picking them based on what best meets the business requirements and needs, and then reduce risk of outages and downtime because you're using multiple cloud service providers. So if one goes down, you still have the other that is up to use. Now that we have covered the service layers like infrastructure as a service, platform as a service, software as a service, and the deployment models such as public cloud, private cloud, hybrid cloud, and multi-cloud, we'll look into the cloud computing environment and its architecture. With all things, just like the cloud, there are several components that are put together to create the cloud. With the cloud environment, there's the front end, back end, networking, service models, and the deployment models. These are all used together to create and run the different services or applications on the cloud. We'll start with the front end. The front end is the user or client side. This is where the user interacts with the interface in order to access the cloud computing services. Examples of the front end include downloading an application on your mobile device to access services such as Netflix on your iPad, or using a web browser on your laptop or computer to access Google Docs to work on your paper. The front end is what communicates with the back end, so that it sends requests, then receives the response, and then displays what you were requesting for in the first place. Then we have the back end. The back end is where most of the work is done, and the place where most people don't really understand or realize what's going on. This is like the engine that runs all of the processes in the back and all the hard work behind the scenes. This is where the cloud service operates and supports the front end by supplying what the front end is requesting for. IBM mentions some of the main components of the back end, which includes back end applications. This is the software that receives requests, processes the request, and returns it for the front end. Then we have the cloud computing services. This is the backend services that allows access to the different cloud utilities. An example would be accessing the storage utility services which enables to upload a file, image, or other data and store it there. Then we have cloud runtime. This provides the environment for the services to run and operate on. This is like the operating system, hardware, and memory. Virtualization is an important aspect of the cloud runtime, and virtualization is the creation of multiple virtual computers, or also known as virtual machines, from a single computer's hardware. This allows for different runtimes to be initialized from the same server. Then we go on to cloud storage. This is the cloud storage where you store files, photos, and other data remotely. These services are flexible and scalable. This means that it's accessible from anywhere and that the storage can expand or shrink depending on the wants or the requirements or needs of the specific entity. The infrastructure is where all the hardware, software, and resources are used to run the cloud. Some examples are the central processing unit, the memory, routers, switches, servers, databases, and more. Then we have the management software. The management software is the middleware which basically handles and manages the communication with the front end and the back end. This makes sure that they are able to communicate together and that things run smoothly. Then there is the security tools. This provides security against potential cyber attacks and just overall provides a better security of the system. It has several components to improve, secure transfers or, usage of the different services and applications. Some of the different types of tools that it has would be virtual firewall, encryption, access control list, IDS, IPS, and more. Now we move on to the networking part. The network is the internet connection between the front end and the back end. It connects the front end users to the back end processes. So the user needs internet access to interact with the interface, such as Netflix, and the back end or cloud service provider should have ample internet to reply to that request, get the movie, and stream it back smoothly, quickly, and efficiently. The cloud has a large amounts of requests, so it is important that it is able to handle all of these requests from different front end users. There may be millions of requests. So some important things that are taken into consideration and managed by the cloud service providers are bandwidth, low latency, throughput, and more. After taking all these things into consideration, they should be able to provide and ensure quick, efficient, and smooth interaction with services and applications. Then we have the cloud service models, which include the infrastructure as a service, platform as a service, and software as a service. These are the services that an entity can choose to run on the cloud. And then we have the cloud deployment methods that was discussed earlier, which is where you can host these different services on. So all of these different parts that were discussed help to create and run a cloud environment. This concludes my portion of the presentation on cloud deployment methods and types and the cloud computing environment structure.
Hi everyone, my name is Ty Davis, and today I'll be talking about how cloud data centers are structured, where they're located, and how reliability and performance are guaranteed, and how new virtual machines come into existence. Basically, this section covers what happens behind the scenes of the cloud, all the physical and virtual systems that keep cloud computing running smoothly every second of the day. So let's start by looking inside typical data centers. Data centers are massive structured buildings that hold thousands, sometimes even hundreds of thousands of servers. You can think of each server as a powerful computer that stores data and run applications for millions of users around the world. These servers are organized in layers. So we have individual servers are stacked into racks. Then racks form clusters, and then clusters form zones, and multiple zones make up a region. This layer structure helps with organization, efficiency, and redundancy. Each server doesn't just run on one operating system. Thanks to the virtualization, a single physical server can host multiple virtual machines or containers, allowing multiple customers to share the same hardware. Data centers also have advanced cooling systems, power backups, fire suppressions, and security systems. Cooling is a very critical because these machines run 24/7, and they generate a huge amount of heat. A redundancy in power and network connections ensure that servers stay online if something fails. So these things are a lot to cool. They are very heavy on electricity and they're heavy on network stuff. So overall, a data center is like the heartbeat of the cloud, a powerful, efficient, and it's always running all the time, like a heartbeat. Where are data centers located? Uh, Cloud providers spread them all across the globe for a few main reasons: redundancy, latency, and reduction, and regular compliances. So basically, a redundancy means if one data center goes down, for example, let's go with Virginia, goes down, uh, Iowa can take over, or um, Iowa or Chicago. But because they're different companies, they have to sign an agreement saying, "Hey, can we please use it?" And sometimes they do, sometimes they don't. So it's very iffy. And these are not the only ones too in the United States. There's many all over United States, but these are just the more popular ones. Then we have latency. The reason why it's spread um, across the world is because if you are in Minnesota, for example, and the data centers are in Florida, it's going to take a very long time to send all the information to your computer or to your network from Virginia. So that's why they're all spread around the world. And the closer the data center is to the user, the faster the connection will be overall. That's why companies like Amazon, Microsoft, and Google have data centers all around the world. And just here are a few examples. We have Amazon Web Servers, AWS, has data centers in North Virginia, Frankfurt, Sydney, and Tokyo, and that is labeled with the yellow countries. Then we have Microsoft Azure. They have major ones in Chicago, Ireland, and Singapore, and that is represented on the map by blue. Then you have Google Cloud, and those are run in Iowa, Finland, Taiwan, and Chile. And again, that is represented by the green. And each of these regions contain multiple availability zones, which are separate data centers by connected by high-speed fiber networks. This means if one zone fails, the other is continuing running, and users won't even notice a difference in downtime. And again, on this map, you can see how widespread these regions are. It shows how much global planning goes into keeping the cloud reliability and fast for everyone in the world. Next, let's talk about how these cloud systems are guarantee reliability and performance. The main techniques are redundancy, load balancing, monitoring, and load balancing and monitoring and disaster recovery. Redundancy means having backup systems for everything, power, storage, and servers. So if a hard drive fails, a duplicate copy is instantly available somewhere else. That can also be somewhere like in Iowa. So if a a power for component is broken, another hardware system right next to it can take over. Then you have load balancing is used to spread workloads evenly across servers so no machine is overloaded. This keeps performance stable even during high traffics. For example, if you are running a virtual machine and you can tell it's going to be using 100% of that compute of that cloud, it's going to separate them so it's evenly, so they're all at like 50% power. So no machine is going at 100, because if they stay 100, it reduces time on the computer and also lessens the lifespan of those machines. And then monitoring is continuously is continuing. Cloud providers use automated systems that constantly check for temperatures, network traffic, and resource usage. If an issue is detected, it's often fixed automatically before it even affects a user. Finally, is a disaster recovery, ensuring that copies of data exist in different regions. If a natural disaster hit one country, another location can take over instantly. For example, if we have the Singapore servers get taken down or the Tokyo servers get taken out by a tsunami, uh, another place can take over instantly. And then most cloud companies guarantee uptime using something called SLAs, or service level agreement, promising availability like 99.99% of the time, which equals only a few minutes of downtime a year. This could be due for updates, uh, installing new servers, or even maybe construction on the data centers. But again, that will be sometimes transferred to different locations depending on how busy they are. And the reliability is what makes cloud computing trusted by businesses and governments literally around the world. And now let's move on to how virtual machines or VMs are created. Every virtual machine starts with a piece of software called a hypervisor. Hypervisors are such as VMware, KVM, or Microsoft Hyper-V, and they sit between the hardware and the operating system. They allow one physical server to be split into many smaller virtual computers, each isolated from the others. So multiple users can share the same physical machine safety. And here's basically the general process of how a new virtual machine comes to life. A user requests a VM. For example, when you launch a instance in AWS or Microsoft Azure or Google Cloud, and then a system such as a OpenStack or AWS management performs checks on hardware availability. So do we have this availability? If yes, here you go. Then the system allocates the CPU, memory, and storage resources needed for a new VM. The hypervisor loads a pre-built operating system image, like Windows or Linux, into the virtual environment. And finally, the VM boots up, connects to the network, and is ready to use. And this process happens in seconds, and it can scale instantly. That's what makes cloud so powerful. It can spin up 100 or thousands of virtual machines automatically based on demand. So if you need more memory, you can just add more memory without even it being physical. And even for the CPU, if you need a better CPU, you could just ask for a new CPU and you will get it. So that is basically what we're talking about for cloud computing. To summarize, cloud data centers are highly structured facilities full of servers and organization into clusters, zones, and regions. They spread around the world for speed, redundancy, and compliances. And then reliability is guaranteed through redundancy, load balancing, and constant monitoring. And finally, virtual machines are created through the hypervisors and the sorry, orchestration. I don't know if I said that right. Systems. That is again the do we have the resources to do it? that allocate resources automatically. All these pieces, the hardware, software, and automation, work together to make cloud computing fast, scalable, and nearly always available. And thanks for listening to our whole presentation uh, that consists about cloud computing and virtual machines. So thank you very much.